In this video, we are going to add and subtract polynomial expressions. I just briefly want to make sure we all understand what a polynomial expression is. A quick example would be something like this: 2x squared plus 3x plus 4. So a polynomial expression has a variable with an exponent. It's an integer exponent. You can have coefficients here like I do with the 2 as a coefficient to x squared and the 3 as a coefficient to x. You can also have a single constant, which in this case would be the 4. When you are adding and subtracting these polynomial expressions, you are doing one very important skill, which is combining like terms. Now, what makes terms like? They have to have the same variables and they have to have the same exponents. So, for example, x to the third can be combined with 3x to the third. Same variables here. Same exponents as well. So if you have x to the third plus y to the third, those are not considered like terms because they are different variables. Likewise, if you have x to the third plus x squared, again, those are not the same exponents, so they cannot be combined. So real quick, these two cannot be combined, but this one could be. Another quick example with more than one variable, if you have something, for example, xy plus 2xy, x squared y, x squared times y plus 2 times x squared times y, this also can be combined into 3x squared times y because they have exactly the same variables and they have the same exponents. By the way, the exponent of y is 1. So they have everything you need and you just simply combine the coefficients. For these two problems, we'll go ahead and add for the first one and subtract for the second one. So what I like to do is, especially with adding, I like to group or identify what the like terms are. So I'm going to put a red line underneath the x squared terms. I'm going to put a purple box around the x terms, or we call those linear terms, and I'm going to put a green circle around the constant terms, and from there I'm just going to go ahead and add them. So my final answer will be 2x squared plus 4x squared, which is 6x squared, 5x minus 9x, which is negative 4x, then you have negative 8 plus 3, which is negative 5. So there's your final answer. Number 2 is subtraction, and I highly recommend doing one thing first before you do actually combine. And this is what for some reason trips up some people, even some very smart, intelligent students. They tend to get a little bit lost in all their signs. So what I highly recommend doing is making this into a -1 coefficient and multiplying everything inside the second expression by that -1, and then you can combine like you did for problem number 1. So everything from the first expression stays the same. So 4y to the 5th minus 3y to the 4th plus 6y squared. Everything from the second expression changes to its opposite. So negative y to the 5th plus 2y cubed minus 9y squared. From here, it's essentially the same problem we just got done doing. So notice here I've got a y to the 5th and another y to the 5th, which makes 3y to the 5th. Notice you also have negative 3y to the 4th, but no other y to the 4th, so that's just negative 3y to the 4th. Also notice here you've got a 2y to the 3rd. There is no other y to the 3rd, so that will just drop down as plus 2y to the 3rd. Now we do have one last term which can be combined. I'll do that in light blue here, and so this is positive 6y squared negative 9y squared, which combines to be a negative 3y squared, and that is your final answer.
What you doing?